My name is Christian Holsing. I work in the OSV team at Intel, covering the open source vendors, meaning mostly the Linux distributors, and I'm working very closely with Canonical, coordinating the different initiatives that we have from an Intel perspective over the various business units with Canonical and driving Intel innovations into the Linux distribution.
And I'm Edoardo Barbieri, Realtime Kernel Product Manager and Industrial Sector Lead at Canonical. We are the company behind the Ubuntu operating system, and we are here today at Hannover Messe in Germany to showcase Ubuntu for embedded devices and our latest announcement, the Realtime Ubuntu operating system.
So from a real-time perspective, there's a lot of movement from workloads from the data centers over to the edge. And basically, if you think about robotics use cases, there is a lot of industrial size machines that control robotics, that control different visual checking of produced goods. And these computers represent a huge workload, and from an Intel perspective, we see the demand one side on the edge and on the other side to really leverage the existing compute power. And from the Intel side, we have built a set of innovation into the chips, starting with 11th generation core CPUs. And we've introduced a set of very dedicated real-time features that are not working simply only out of the silicon. They will need a software component. And based on the long-standing partnership with Canonical that we have, where we have just recently released a set of IoT images together that are optimized for Intel silicon, it was just a very natural step for us to partner with Canonical here and do joint work on real-time and get that to market together as well.
And to add to that, at Canonical, we are part of a rich and vibrant community. So we partner with the ecosystem, from OEMs to ODMs to the silicon vendors and the hardware manufacturers, so that we can offer out-of-the-box solutions for our end users. And this does two things. On the one hand, it accelerates the time to market, but it also shortens the time to value for the consumers, for the device consumer. So essentially, it comes down to the leading distro for developers, Ubuntu, joining forces with the leading silicon manufacturer, Intel, to be able to offer a combined solution that works out of the box for our end users. A real-time system has well-defined fixed time constraints. If the processing of the compute tasks is not performed within an upper boundary of time, the system has failed. It results in a catastrophic consequences and failure for the overall system. And in the Linux kernel, at the kernel level, real-time denotes the deterministic response time to the external compute tasks. And what we recently included in the Ubuntu operating system are the Preempt30 set of patches. And with Preempt30, we are enabling real-time capabilities into the Ubuntu operating system.
So from a hardware perspective, as I said before, Intel has put a lot of innovation into the Intel Core 11th generation onward CPUs that basically bring real-time features like time-coordinated computing, TCC, which includes TSN, time-sensitive networking, with the chips to market. As we said earlier, we are collaborating very closely with Canonical, for example, here to really enable the full stack, because it's not only the hardware features, it's also the software that needs to take benefits of it from an operating system perspective and also the application perspective. So going back to TCC, if you think about what we do on the hardware perspective, then it's really that, as soon as the CPU is getting more utilization, there's basically more traffic, more coordination needed, and TCC on the hardware really enables isolation of the real-time workloads in multiple ways. For example, isolation of the cache access, isolation of the execution from non-real-time workloads, so that you really get a predictable response time in the limits of the real-time workload that you're expecting from the complete stack, hardware and the software side.
So this demo is a prime example of the partnership between Intel and Canonical. And this demo is a scalable testbed to illustrate real-world, real-time industrial usage scenarios together with Intel, bringing the real-time Ubuntu technologies and Intel TCC capabilities. So Christian, you want to illustrate some of the technical aspects of this demo?
So what we see here in this demo is basically a servo that is controlled by an industrial-grade PC that has the Intel real-time features enabled on it and is running Ubuntu real-time. And basically a display that's showing us what's happening on the machine. So when we basically look at the demo right now, we're putting, besides an algorithm that's moving the wheel forward in a predictable space, predictable degree, also additional load on the machine to just illustrate how customers can actually leverage their environment best. So what we see right now is basically the wheel spinning in a very predictable way and a real-time way, so as you would expect it from a real-time compute system, that even with load you get the expected results and a very steady movement. But when we now turn off the Intel real-time features here in this algorithm, then we see the wheel immediately spinning pretty crazy, because there is interference between real-time and non-real-time workloads on a high-loaded CPU. And through the TCC features that we have on the chip, we're able to isolate the workloads much better. And with the enablement from the Ubuntu side, we're able to really create this predictable result here for industrial-grade use cases. So we see from an Intel perspective a huge demand on the edge. So workloads are actually moving out of the data centers towards production floors, shop floors. There's a lot of edge computing that happens, and there is a set of new requirements, like the real-time requirements that we're actually talking about here at Hannover Messe. So we have a long-standing relationship with Canonical, so they have enabled and optimized their Linux distribution for Intel technologies, Intel innovations. We just recently brought IoT images to the market that are Intel optimized and just out of the box enable a set of key new Intel features. And it was just very natural to do the step here for real-time as well and collaborate to get the Intel TCC features embedded in Ubuntu and go to market together, so that joint customers can just simply take Intel Silicon and the Ubuntu Linux operating system and start building their application on it. And obviously a plus was also the usage of Ubuntu in the developer ecosystem. So, because that's just key in this context, a lot of these solutions are being developed, and the ease of use for a developer to just get a pre-integrated stack and know the technology is enabled and even supported from a Canonical perspective is, I think, really a plus.
And another aspect here to understand is that we are truly looking at an overall real-time stack. So from the underlying hardware all the way to the operating system, the networking and user space layer. And a real-time kernel on its own will not necessarily make your system real-time. Often your hardware configuration has to be set up for it, and even the most efficient RTOS could be useless in the presence of other latency sinks. So tuning for each distinct system is often required. And this is the reason why we decided to partner with Intel, so that we can optimize the entire real-time stack, from the underlying silicon to the operating system layer, as well as networking with Ethernet-based TSN. So a real-time kernel on its own is only part of a real-time system. And this is why we are partnering with Intel to be able to deliver an out-of-the-box, fully functional solution. So from a canonical point of view, we are optimizing and tailoring real-time Ubuntu images on Intel hardware by tightly collaborating with the Intel engineering teams. So this has been a long and extensive process of going all the way from tailoring the specific Ubuntu features on the Intel silicon, as well as going through extensive testing in our QA labs, as well as shipping the Intel hardware with Ubuntu images on our labs in Taiwan. And specifically on which silicon are we shipping real-time Ubuntu?
So that's basically relatively simple. So what a customer would need is the CPUs that support TCC, the respective SKUs, as we call it from an Intel perspective, from the 11th generation onward. So it's basically codenamed Tiger Lake, Alder Lake, Raptor Lake onward, where the features are available to the market.
So if you think about the definition of a real-time system, one with a fixed and well-defined time constraints, where the consequences of missing a deadline can be catastrophic, all sorts of scenarios may come to mind, from life-supporting medical equipment to healthcare robotics, also in automotive applications. So we see different verticals, like telco as well, requiring real-time. One of the key sectors where we're seeing demand for real-time Linux is also industrial. This is both for discrete automation as well as for process automation. And what we're actually seeing in the market in industrial is the transition from closed standards and proprietary interfaces towards the adoption of open source software and open standards and open interfaces. And Linux with real-time capabilities as well as Ethernet-based TSN is actually underpinning this transition. In the past, the different factories, the industrial PCs were mostly used for HMIs or some data gathering, but we are now starting to see the demand for real-time compute at the edge as well. So whether it's industrial PCs or edge servers, they're all requiring real-time capabilities to deliver the processing of the workloads in a production line, as well as for the shop floor where the different devices are being operating.
So it's very similar from the Intel side to what Eduardo was just saying in the use cases that we see. It's actually broadening, right? So, I mean, in the past, the natural use case was probably in an industrial robotic control area, but we see automatic movers that on factory floors move like goods from A to B to the production lines. But there are also use cases in healthcare, for example, if you think about processing of images, if you think about surgery robotics again, and then there is the whole notion of displays, right? Where in the past you had one PC controlling up to 4 displays. Right now we see these enormous video walls that need to be coordinated. And there is a clear demand for real-time right here. If you think about 20 or so displays that need to be in sync, that need to show one picture in the end, right? Then what we've been talking about here, TCC and TSN, really comes into play, right? Because it's not one machine anymore that controls these enormous displays, it's multiple machines. So there is a trend of, more smaller compute form factors rather than a big server. And if you think about real-time, then there are really different dimensions even towards real-time, from something that is in microseconds of real-time towards something that's in milliseconds of real-time. And that's what we're really working on, and why we work with various partners like Canonical to really get the Intel innovation, the Intel technology to market and in the hands of our customers that actually build the applications of it.
So beyond the technical features and the optimization of real-time Ubuntu on Intel, one aspect that I think we should really stress and focus on is the long-term support and maintenance on both the hardware and the software layer that will come with real-time Ubuntu on Intel Silicon. So when you ship your embedded devices in production, they have to last throughout their entire lifetime. But with the long-term support for up to 10 years from both Canonical and Intel, from the tight collaboration, you're able to leverage your embedded Linux devices without having to worry about the over-the-air updates, CV fixes, patches, etc. to the operating system, as well as to the support for the hardware layer. So you can only focus on your value-added application, you can focus on your intellectual property without worrying about what's underneath that value, without worrying about the rest of the stack that together brings your device into production. And from an Intel hardware perspective, what's the added value? What does Intel bring to the table in terms of support and maintenance?
So I think actually you're touching on a really important point here on support, because if we think about an industrial use case, we usually see longer lifetimes of the machines. And with that perspective, I think the partnership here and the offering from Ubuntu Pro for a long time support is something that really makes sense. As really said before, right? I mean, there's the hardware aspect, but there's also the software aspect. And only together, if we have aligned the support life cycle here, we can actually bring a value to the joint customers and can actually address their needs of building the application once and doing upgrades and lifetime decisions on their own pace on the software, rather than being pushed by every half year a new Linux kernel or an update or these kind of things. So really from an Intel perspective, it's critical for us to have a reliable software stack that's basically addressing the customer needs and that is in sync, ideally, with the support lifecycle of the Intel products and the hardware, right? And I think there's also an aspect you didn't touch on, which is the question of, I have probably thousands of machines out there that are in fact PCs, and how do I manage and update them, right? And I think that's also a critical piece of an industrial customer, of an industrial end user, to have a solution for that aspect and really be able to manage the thousands of devices on the production floor or out in the field in a meaningful way. And as Intel really doesn't do this part of the software side right now, it really makes sense for us to work very closely with Canonical.